Mark Rosengarten. Welcome to
Ask Rosengarten.
Hey everybody, welcome back to Ask Rosengarten. Sorry I haven't put a video up here in a while, but it's been an absolutely insane week. But I do have a question here today. It's from Katie Campbell. She says, calculate the number of moles of oxygen required to combust 675 grams of ethanol, C2H5OH. Okay, that's fair enough. The first thing you need to do is to write the reaction out. So you have ethanol plus O2 forms carbon dioxide and water vapor. The second thing you need to do is balance this reaction. It's kind of a pain in the butt to balance this reaction because oxygen is split between two substances on the left side and between two substances on the right. Balancing the oxygen is actually the key to this whole problem. Once you have this reaction balanced, it's just a simple case of basic stoichiometry to get you there. First thing you need to do is convert grams of ethanol to moles by dividing by the formula mass of ethanol, which is 46.0 grams per mole, which comes out to 14.7 moles, 3 sig figs, 3 sig figs, 3 sig figs, of ethanol. Now we need to multiply it by the ratio of oxygen to ethanol. There are 3 oxygens for every 1 ethanol. And that means we're going to have 43.2 moles of oxygen when we're done. So you need 43.2 moles of oxygen to completely react with 14.7 moles of ethanol to completely combust it. 14.7 moles we get from dividing the grams we're given by the gram formula mass. Once we have the moles, we have to use the stoichiometric ratio using the coefficients of our desired substances. Now you can go further from here. You can take moles of O2 to liters of O2. If you want to find out how many liters of O2 this is at STP, you just multiply it by 22.4 liters per mole. This is going to tell you how many liters of oxygen at STP you're going to need to completely combust the ethanol. If you want to find out how many grams of oxygen it's going to take to completely combust the ethanol, then you multiply it by the gram formula mass of oxygen, 32.0 grams per mole. And that'll tell you how many grams of oxygen it's going to take to do the job. If you want to find out how many molecules of oxygen it's going to take to do the job, you just simply multiply it by the number of molecules in a mole. 6.02 times 10 to the 23rd molecules per mole. And that'll tell you how many molecules of oxygen. Of course, you're not going to sit around counting out 1, 2, 3, because there aren't enough seconds in the universe to figure this out. So the coefficients of the balanced reaction are your key to doing stoichiometry problems. You have to remember to do this step. Multiply the moles of given by the ratio, coefficient of target over coefficient of given. This will give you moles of target, and then you can do whatever the heck you want to with it. And our other question comes from Eric Rothensee, who asks that he wants to know the oxidation number of CaClO4-2. Well, I can't give you the oxidation number for calcium perchlorate because, well, the charge of a compound, all the charges add up to 0. But I can show you how to determine the oxidation numbers of all of the elements in calcium perchlorate. Here's how it's done. Now the key here is to remember that when you add up all the charges, all the pluses and the minuses, they're all going to add up to 0. Now it's easy to take a look on the periodic table and find calcium's charge is +2. That's the only oxidation state that calcium has. It's got 2 valence electrons. The only thing it can do is lose them. So +2 charge. Oxygen has an oxidation number of -2. Unless it's part of the peroxide ion or the superoxide ion, in which case it's a different charge. So what we've got here is chlorine. Now you might look on the periodic table and say, hey, wait a minute, chlorine's a group 17 nonmetal. So it's got 7 valence electrons. It needs to gain 1 to become a -1 ion. Now that's true under most circumstances. If all we had was CaCl2, then the calcium would be +2, and the chloride, well, would have to be a total of -2 to cancel it out, so each chloride ion would be -1 in charge. But you see, the bond between chlorine and oxygen here is not an ionic bond, so you're not going to use chlorine's ionic charge. Chlorine has a bunch of positive oxidation states that we use when we're finding out with a polyatomic ion. So, let's get chlorine's charge. Calcium contributes a total of +2 to the total charge of this substance. Oxygen contributes 8, 4 times 2 is 8, times -2. 8 times -2 is -16. So whatever chlorine is, it has to be such that these numbers all add up to 0. So let's see, we got +2 on this, we got -16 on that. Obviously chlorine has to be positive in order to bring this all up, so it's -16 and +16. Let's see, we got +2 already. We need positive what to make it +16? Yeah, +14. Now that +14 charge is distributed between the 2 chlorines in the compound. So each chlorine is +7 in charge. So calcium's got an oxidation number of +2, chlorine has an oxidation number of +7, and oxygen has an oxidation number of -2. You can use this technique to find out the charge of any element in a compound. The new semester started, things are crazy at school, but I'm still going to do this at least a few times a week. So keep sending me your questions to askrosengarten@gmail.com, and I'll get back to you as soon as I can. So what are you waiting for?
Ask Rosengarten!